Welcome to Ask and Learn.
We will sketch the graph of the function given by this expression. It's a piecewise function. The first part, or piece, is 2x plus 1 for x greater than or equal to 0 and less than 1. And the second piece is 4 minus 2x if x is greater than or equal to 1 and less than or equal to 3. So it's a piecewise function with two pieces. Both pieces are straight lines. In this case, they will be segments. And the domain of the function defined that way is 0, 3, close interval, close both endpoints. In the first piece, 0 is included, but 1 is not included. And in the second piece, both 1 and 3 are included. So let's draw first the line 2x plus 1 for x greater than or equal to 0 and less than 1. At 0, the line 2x plus 1 has the value 1. So, and it is included. So we have this value here, this red dot here. Then at 1, it is not included, but if we calculate the value as 1 of the piece 2x plus 1, we get 3. That means that at 1, we will have the value as 3, but we indicate it's not included with this open circle here. And then we draw the line between those 2 points. Let's see if we can fit it well here. Almost there. So we're here. This is a line. It's a segment, in fact, because x is in the interval 0, 1, including 0, not including 1. And now the second part is second piece, a straight line again. And for x equal 1, the image is 4 minus 2, which is 2. So at 1, the value is 2. So this, and it is included in the graph, that is this point here says that we are including it in the graph. And for x equal 3, we got 4 minus 2 times 3, that is 4 minus 6, that is negative 2. So at 3, we have negative 2, and it's included in the graph also. We have to join the two lines, and we see that we have to cross the x-axis at 2, because at x equal 2, we get 0. So we draw a line, something like this, and then we fit better. So there's a line. It's a little bit longer than we need, and that's it. So this is the line, and we see it crosses exactly at x equals 2, because the image of 2 following the second piece is 4 minus 4 is equal to 0. So we have this discontinuous function here, and we can see that we have an absolute minimum value over here at this point. This is the lowest point in the graph, and it's included in the graph. That's why it is the lowest point. So f has an absolute minimum value of negative 2, and that value occurs at x equal 3. With respect to local minimum values, We don't have local minimum values because, for example, this point here, we have no function to the left of that point. It could not be a local minimum. At this point 1 here is not a local minimum because if we take any interval around 1, a small interval that is we are close to 1, there are images that are smaller of the image at 1, which is 2. If to the right we have smaller values, and to the left we have greater values in this other part of the function. So 1 is not a local minimum, and there are no more possibilities of local minimum, so f has no local minimum. And with respect to the maximum values, there is no absolute maximum because the highest point should be this point, but it's not included. So there is always greater values that get closer to the image at 3, at the value 3, but never reaching it. So f has no absolute maximum, but it don't have also local maximum because the same reasoning we did before. There is at any point that we choose on the graph inside the domain, not the endpoints, there are always images that are greater and smaller than the image at the point. So f has no absolute or local maximum values. So the only thing that this function has is an absolute minimum value, -2 at x equals 3 at the writing point of the domain. And so this is the result in this problem.